Hello everybody, we are going to be doing a homework helper for section 5.9 and I have a live studio audience, which is my first period class. Guys, say hello.
Hi!
Alright, now stop talking. Alright, so in this very first section what we're going to have is it gives us a couple geometric questions. It wants us to match isosceles triangle, equilateral triangle, scalene triangle, right triangle. It wants us to match what all of these are to the definitions below. This is going to be a little bit of either review or research for you guys. You either have to review it or research it, right? Like you might know that an isosceles triangle is where only two sides of the triangle are the same length. You probably have seen this at some point in your mathematical careers. But you might be at a point where you're like, you know what, I don't remember what an equilateral triangle is. If that's where you are, then you're going to have to just Google it. I want you guys to get used to using your resources in finding information as it relates to math. If this were a word you didn't know in English class, you would grab a dictionary. You would look it up. Well, this is a word we don't know in math class. And you should have at some point looked at what equilateral triangles are. But in case you didn't, you're going to have to do that on your own. You guys have these supercomputers in your pocket that I have to constantly tell you to put away. So you guys have access to this information. You don't need me to say what an equilateral triangle is. You can find out what an equilateral triangle is. But in case you didn't want to wait that long, an equilateral triangle is a triangle where all sides are the same length. So that's going to be 2. That's going to be a B right there. All right. Moving on. This is the hard stuff right here. We are going to solve systems of equations by using the elimination of a variable. So I'm actually going to zoom in on number 9 here. Let's move that out of the way. And so when we're talking about elimination of a variable, this is very similar to what we were doing yesterday when we were looking at the different dog and cat food prices, except we're going to do it algebraically instead of trying to reason about it. So when I have something like 2x plus y equals 3 and 2x plus 2y equals 2, I am going to be trying to eliminate a variable by adding or subtracting the equations together. So look at what happens here. We see that my x is above my x, my y is above my y, my equal is above my equal, and my constant is above my constant. These are both in standard form. They are both in the same form. And as long as they're both in the same form, we can solve this with elimination. So here's how elimination works. Essentially what you do is you line it up and you subtract one of the equations from the other. So in this case, I'm going to subtract the second equation from the first equation. So I have 2x minus 2x, that becomes 0. Now this becoming 0 is why I chose to do this. This is why I chose to eliminate. Some problems, we're going to have to manipulate one of the equations so that they will eliminate. This is going to be like yesterday where sometimes we had to double some of the equations so that it would eliminate properly. So in this case, we didn't have to do that. It was already lined up. So 2 minus 2 is 0. 1 minus 2 is negative 1, so negative y. And then 3 minus 2 is 1. Any questions on how I did that? Okay, I just subtracted the second equation from the first equation through this process of elimination. I subtracted this from this, this from this, and this from this. So then I have a one variable equation. Yeah?
When you subtracted 2y from just y, would it become negative 2y instead of just negative y?
So he was asking about this step here and how this worked. Essentially what we're looking at is we're looking at our coefficients here. While there isn't a written coefficient on this y, we always assume that there's an invisible 1 there. So if I do 1 minus 2, I get negative 1, and that's why I end up with a negative y. Good question. Any other questions on this? Okay, so now I have negative y equals 1, and so I need to solve what y is. Right now I know what negative y is. So to get rid of this negative 1, we can do all sorts of things. We can divide by negative 1. Okay, that reduces down, so that becomes y equals 1 divided by a negative 1. Whoops, I was off the screen. Is negative 1. So now I have my y value. I know that y is negative 1. So I know that where these two lines cross, right, because it's a system, we know that they're lines, I know that where these two lines cross, the y value is -1. I just need to find the x value now. And I do that by just substituting -1 into any of the equations. So I'll just pick this one. I go 2x plus y equals 3, except now I'm going to substitute -1 in for y. So I get 2x minus 1 equals 3. Now I just need to solve for x. I'll add 1 so that 2x is 4. I'll divide by my coefficient of 2 so that x is 2. So now I know that my grand answer is the point 2 comma -1. I'll put it in a box. I'll put a bow on it. And I'll give it to you. There you go. Okay. So those are the steps to being able to do these ones. Okay. The first thing we have to do is we need to eliminate a variable by subtracting one from the other so that one of the variables becomes 0. We then have a one variable equation. We can always solve one variable equations and get an answer, and we found out it was -1. And then we have to take that value, whether it's x or y, plug it back into any of the other equations and solve for our other variable. Once we have both variables solved, we have our point. Any questions on this? Okay. We are going to hit some wrinkles with this. I'm going to ask you to do things where maybe these don't line up as nicely. All right? And I'll actually look to see if there's one of these on here. Okay, I'll do number 12 real fast as well, because this is one of those ones where it requires a couple of extra steps. So when I'm looking at number 12 here, we see that, I have 3x plus 5y equals -1, and then x plus 2y equals -1. And what we see here is yes, they're both in standard form, but 3 minus 1 is 2, 5 minus 2 is 3. I don't eliminate any of my variables, and I want my variables to be eliminated. So if this x were 3, if it were a 3x instead of a 1x, I know that it would eliminate when I subtracted it. So to get this to become a 3x, I have to multiply the entire equation times 3. So when I do that here, this becomes 3x, and then 3 times 2 is 6y equals, and then -1 times 3 is -3. Okay? Now, I'm going to pause right here and make sure we're all good. You guys understand how I did that? I just multiplied everything by 3. And technically I multiplied both sides of the equations by 3. I did it out here as a shorthand, but I hope you guys see that this is just multiplying the left side by 3 and the right side by 3. Okay, I'm doing both at the same time. So now that I have the left side multiplied by 3, the right side multiplied by 3, I'm just going to rewrite that first equation here. 3x plus 5y equals -1. And now I can eliminate. I can subtract the second equation from the first. So 3x minus 3x is 0. That's why I did that first step. 5 minus 6 is a -y. And then -1 minus a -3. So whenever I subtract a negative number, it's the same as addition. So -1 plus 3 is 2. Okay, I can now divide by -1. I get y equals -2. Okay, I'm halfway there. Oh. Living on a prayer. Take these variables and plug them in, I swear. Yeah, okay, medium minus. You guys, I get a C for that song. C minus for that song. That's fair. Okay, so I'm going to take this now, and I'm going to plug it into one of my other equations. I'm just going to choose the top one. You could choose the second one. It doesn't matter. I just choose the top one because it's the top one. So if the top one is 3x plus 5y equals -1, I'm now going to plug -2 in for y. So this becomes 3x plus 5 times a -2 equals -1. I'm now going to evaluate that. So I have 3x minus 10 equals -1. I have two terms on the left. I want to isolate my x term, so I'm going to add 10. So that 3x is 9. And then finally, I want to get x by itself. So I'm going to get rid of that coefficient of 3 by dividing by 3. I get x equals 3. And so I have my point 3, comma, negative 2. Put a bow on it. Send it to somebody you love. All right. So those are the types of problems that I'm really going to expect you guys to be able to do. Like, this is the type of skill that you guys need to have as you move into geometry and then algebra 2. Part of me is tempted to just have our chapter test to be one of these problems. Just one of them where you have to explain how you did it. Because this is one of the key problems of this entire chapter. I'm not saying I'm going to do that, but I'm saying I'm considering it. All right, let's go ahead and turn the page. Number 14 is the same type of problem, except it's written as a word problem, so you're going to have to create the equations yourself. Finally, the go section. It says for each graph, determine if the relationship represents a function. If it is a function, write yes. If it's not a function, explain why it is not. So I hope you guys remember a wonderful test that we have for determining whether or not something is a function. We call it the vertical line test, where you take a vertical line and you drag it across. So 15 here passes our vertical line test. So this, yes, is a function. And then something like 18, when we do our vertical line test, we see that at any vertical line it crosses twice. So we would say no, but we'd also explain why fails the vertical line test. Okay, and that'll be that. Any questions on functions for determining this? This is just a quick little review. Yes?
Could you explain the test one more time?
So the vertical line test is what you do is you take a vertical line. In this case, I'm using my pinky to represent that vertical line, and you drag it across the graph. And for it to be a function, your vertical line should only touch the graph once and only once at a given time. So if as it passes through, I see that it actually touches the line twice. So that means that that line does not represent a function. Whereas for number 15, as I do it, I see that I'm only touching it once at any given time. Thus, it is a function. Yes?
Unlike vaccine where there's like an open circle, right?
So he's asking about this closed circle and open circle. Remember, the open circle means that that is not a point. That means it comes really close to that point but never touches it. So when we see right here where we have a closed circle and an open circle existing in the same space, it's on that vertical line, it's only touching it once right here. The open circle, it's not actually touching it. So that would be a functional relationship. At least at that point. I'm not talking about the rest of the graph, just that point. Okay. Any other final thoughts? All right, guys. You're a wonderful audience. I'll have you back again sometime. And let's get to work.